Hey kiddos! Today we are going to be talking about a few other type of quadrilaterals, which actually are special types of parallelograms, and they are the rhombus, the rectangle, and the square. So a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles, and a square is basically the child of a rhombus and a rectangle put together, because a square is a parallelogram with four congruent sides and four right angles. Okay, so let's look on to some of the characteristics of each. A rhombus is a quadrilateral if and only if it has four congruent sides. So ABCD is considered a rhombus if and only if AB is considered congruent to BC, which is congruent to CD, which is congruent to AD. A rectangle is a quadrilateral if and only if it has four right angles. So this ABCD is a rectangle if angle A, angle B, angle C, and angle D are all right angles, which means that they have measurements of 90 degrees. So a square is a is a quadrilateral if and only if it's a rhombus and a rectangle. So remember what I was saying before is basically if a rhombus and a rectangle were to get married and they had a child, they would produce a square. So notice all the sides are congruent and all the angles are right angles. Going back to a rhombus. Rhombus has a diagonals theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if these two diagonals are in fact perpendicular to each other, which means they create that 90 degrees when they intersect, then this is a rhombus. A rhombus also has opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So notice here, angle B is split into two congruent pieces, along with angle A, same thing, along with angle D, and along with angle C. And still, opposite angles are still congruent to each other, okay? So that's what you're seeing here with the rhombus opposite angles theorem. Now, the rectangle also has a diagonals theorem, but it's different from a rhombus. A parallelogram is a rectangle if and only if its diagonals are congruent. So the diagonal from A to C is congruent to the diagonal of D to B. Okay, so that happens in a rectangle. Their diagonals are actually going to be congruent. Now, what we have here is a family tree, essentially, because quadrilaterals are part of a family, and they're part of the four-sided family. Now, from quadrilaterals, we can branch into three things, and that is the parallelograms, that is trapezoids, and that is kites. All of these items, all of these shapes, all these polygons have four sides. They make up quadrilaterals. Now, from here, parallelogram can actually be broken down further into a few more groups, and that is the rhombus, and the rectangle. And we've talked about that if a rhombus and a rectangle got together, they create together the famous square. Now, the only addition that I would add to this is that we have a trapezoid, but we actually have something also a little bit more special than just a trapezoid, and that is the isosceles trapezoid. And we'll get into these other two types later. Right now, our focus is in the parallelogram world with the rhombus, the rectangle, and the square. All right, let's look at our first example. We are going to classify this special quadrilateral and explain our reasoning. So, is this quadrilateral parallelogram? If it is a parallelogram, then can we go a step further and classify it as a rhombus, a rectangle, or a square? Now, we know that a rectangle and a square have to have 90-degree measures, and this clearly is a 70-degree, so I know it can't be those two. So, the other key factor that I have here is that all sides are congruent, which basically would say that this quadrilateral is not only a parallelogram, but it is actually more specifically a rhombus. And the reason why is that all sides are congruent. Example 2. For any square JKLM, it is always or sometimes true that JK is going to be perpendicular to KL. Explain your reasoning, draw and label a picture. Go ahead and pause and let's draw a picture of square JKLM. Alright, so hopefully you have your picture drawn of the square JKLM. Now it says here that is it always or sometimes true that JK, so in this case if I got JK and KL, that they're going to be perpendicular. Perpendicular meaning that when those two lines intersect that they create a 90-degree angle. And in this case, that will forever and always be true because this is a square. And when these two sides do meet, it will always create a 90-degree angle. So, always. And the reasoning is that squares have all 90-degree angles. Have all right angles. Example 3. For any rectangle EFGH, it is always or sometimes true that FG will be congruent to GH. Explain your reasoning, draw and label the picture. Picture time. Let's peep that. Alright, so there's my picture, and we're looking at FG being congruent to GH. Now, here's where you do have to be careful with wording. Alright? The answer to this is going to be sometimes. And the reason why is that it's only true when EFGH is also a square. So remember here, this is why you do have to kind of be careful with wording, because a square is technically a rectangle, just like a square is technically a rhombus, okay? So always keep that in mind, especially when you're dealing with these kind of situations like this problem, all right? Example 4. A quadrilateral has 4 congruent sides and 4 congruent angles. Sketch the quadrilateral and classify it. I think you all can handle it on your own. All right, example 5. We're going to be looking for some angle measures in a rhombus. So find the measures of the numbered angles in rhombus A, B, C, D. So they're already telling us that this is a rhombus, okay? So a few things, few characteristics to make sure you remember about a rhombus. Opposite angles are congruent, and on top of that, each angle is actually being bisected. All right? Each angle is being bisected. So, oh, and the other one is when two diagonals intersect, they create what we like to call 90 degrees because they're perpendicular. All right? So, looking at our rhombus, we can establish that angle 1 has to be 90 degrees because diagonals are perpendicular to each other. That has to be 90 degrees. All right. Now let's look for angles 2 and 3. Now, I clearly see here that this angle, this piece right here, this angle DCA is 61 degrees. Now remember, we know that opposite angles are congruent, and these two sections are going to also be the same. So therefore, I can classify that angle BCA is also 61 degrees. So that tells me then that angles 2 and 3 are going to have to be congruent to this over here. So angle 2 is 61 degrees, and angle 3 is also 61 degrees. Now to figure out the next part, angle 4. Now, I know angle 4 is going to be split into two congruent pieces, so it's going to help us out if we can figure out what this whole angle is, because then I can just cut it in half and know what angle 4 is. So we're going to have to use some knowledge about parallelograms, okay? Now, we know that angles 2 and 3 are both 61 degrees. So therefore, this whole angle here is 122 degrees. Now, because a rhombus is a parallelogram, then we can also recall that consecutive interior angles are, you got it, supplementary. So, if we were to do 180 minus the 122, we're left with 58 degrees, which means this angle here, ADC, this whole angle is 58. So to find out what just one little piece of it is, because it's a rhombus, we know it's being bisected. So half of 58 leads us with an answer that angle 4 has to be 29 degrees. All right, example 6, very similar. They're telling us that it is in fact a rhombus. Okay, so a few things that we should recall about a rhombus. Well, we don't have two diagonals, so I don't have to worry about any perpendiculars, but we do want to remember that opposite angles are congruent, and that opposite angles are also bisected. So, and throw in there what pertains to parallelograms in general is that consecutive angles are supplementary, right? So, from the get-go, I see that we're going to have to deal with the consecutive interior angles. So, therefore, I automatically know that to figure out what angle D is, I'm going to have to take 180, subtract it from 118, and I'm left with 62 degrees. So, angle D is 62 degrees. But I need to figure out what angle 1 and angle 2 is. Now, the nice thing is, because it's a rhombus, this is being bisected. So I just take 62 and divide it by 2, and we get 31. So angle 1 is 31, and angle 2 is 31 degrees. Now, the nice thing about a rhombus is the opposite sides are opposite sides. I keep saying sides. Opposite angles are congruent. So therefore, 3 and 4 would be the exact same answers as 1 and 2, which is not 62, it is 31 degrees. All right, moving on. Finding diagonal lengths in a rectangle. So notice we're switching it up. We're now going to a rectangle. So what do we have to recall about diagonals in a rectangle? Hopefully you're saying that they are congruent. So in this rectangle, QRST, we have that QS, which is this whole diagonal, is 5x minus 31. And we have that RT, which is the other diagonal, is 2x plus 11. Find the lengths of the diagonals. So we know that they're going to be congruent. So to set up our equation, we would simply just have them equal to each other. So 5x minus 31 equals 2x plus 11. Now all I have to do is solve for x, plug it in to figure out what is the actual measure or length of the diagonal. So I'm going to subtract 2x to both sides. 3x minus 31 equals, that canceled out, 11. We're going to add 31 to both sides. So we get 3x, that canceled out, equals 42. And the last step is to divide both sides by 3. We get x by itself, which is what we want, and 42 divided by 3 is 14. That's not our answer, though, because the question says, what is the lengths? So now all I have to do is plug it into one of them. I don't have to plug it into both because they're going to be the exact same answer. So I'm going to go with the 2x plus 11, which was RT. And I'm going to plug in the x as 14 because that's what we worked out. So 2 times 14 is 28. 28 plus 11 leaves us with 39. So our T is 39, as is QS, because diagonals of a rectangle are congruent. Okay, so final example. Decide whether parallelogram ABCD with vertices A is at -2, 6, B is at 6, 8, C is at 4, 0, and D is at -4, -2 is a rectangle, rhombus, or a square. Give all names that apply. Explain your reasoning. So, first thing that we need to do is make sure that this actually is going to be a parallelogram, meaning that the opposite sides are actually, in fact, parallel, which means we gotta peep that slope for this. So, from A to B, we go up 2. So we go up 2, and then we go to the right 1, 2, 3, 4, 5, 6, 7, 8. To the right. So that's positive, positive. 2 over 8 reduces to 1 over 4. All right, next one, BC, B to C. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. We're going down 8, and to the left 1, 2, left 2, which that's a -8 over a -2, which reduces to a positive 4. Now, hopefully you're noticing here that AB is not supposed to be parallel to BC. All right, so technically we're okay right now. So now let's look at CD. CD is supposed to be parallel to AB, so we hopefully get the exact same slope. Let's check that out. So from C, I'm going to go down 1, 2, down 2, and to the left 1, 2, 3, 4, 5, 6, 7, yay, 8, left 8. So that's -2 over -8, and that does reduce to a positive 1/4. Now the last one, slope AD, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the right 1, 2. And those are all positives, and that does give me a positive 4. So far, so good. Now, for this next part, we actually need to figure out, are these sides congruent? Does AB the same distance as DC? Is BC the same distance as AD? To help us figure out if it's a rectangle, rhombus, or a square. So, what you would use is Pythagorean theorem. And lucky for us, since all of these have the same number values being used, we only have to use Pythagorean theorem once to figure out their distance. And that's the quickest way to do it. I mean, technically we could sit here and we can use the distance formula, but that's going to take a lot longer. So we're not going to do that. We're actually going to just plug it into Pythagorean theorem. So we have our A and our B. So that's 2 squared plus 8 squared equals C squared. 4 plus 64 equals C squared. And you'd end up with 68 equals C squared. And the last step would be to take the square root of 68. And for radical purposes, we're just going to leave it in that radical form. All right. So the distance then for all of them is going to be the square root of 68. Now remember, the reason why I know that they're all the same is because on all of the right triangles that I created, we had 8 and a 2, 8 and a 2, 8 and a 2, 8 and a 2. So all of them have the exact same A and B values. So that's how I know and justify that all their answers are going to be the same. So can it be a rectangle? No, they can't be, because we could clearly note that the angles were not equal to 90 degrees. Can it be a rhombus? Technically, yes, it can be a rhombus. Why? Because we established that all sides are congruent. We have the proof there. And in a rhombus, the degree measure doesn't have to be 90. Can it be a square? It cannot be a square because, again, in a square, angles have to be 90 degrees, and in this case, we do not. So, this shape is, in fact, not just a parallelogram. More specifically, it is a rhombus. All right. Ciao.